Okay. Yeah. Okay, shall we start?
Is your mic on?
Mic is on, I think. Is it on?
Got a red light?
Can you hear?
Got a red light on your...
Yeah, I got a red light there. Okay. Okay, welcome to the Silicon Valley Fourth Interest Group meeting. And, you know, traditionally the morning session is called the formal session, which stands for Fourth Modification Laboratory. And, you know, it's just what have you done lately with your fourth system? That's what the, because we all tend to modify our fourth systems. And this morning, what I want to talk about is this, the LaunchPad. Okay, this is the LaunchPad. I got the original box here, and one of the little. So the LaunchPad, it is, I think, first started in 2010 or 2011, and when Texas Instrument first released this, not the first release, but they built a kit for their MSP 430 chip, and they tried to promote it. So that the kit is selling at, because it is a 430 chip, they are selling this kit at the $4.30. So I think lots of people get excited. $4.30. That's including shipping. Okay, you pay for $30 and you get this kit. And I think generally it costs $5 to just to ship it. So we got it, but at the time they have it has a 20 pin dip socket. Okay, and this at the time the chip delivered on this kit was a 14 pin chip. So there's 6 pins exposed. So the chip, that's the I think G2231 or something like that. It only has 2K of flash memory and 512 bytes of RAM memory. So it really cannot do much. Okay. It's an interesting kit for $4.30. Well, why not? So I bought it and found out only 2K flash, nothing can be done. So it's put it on shelf for a while. And then the Taiwan FIG group, a fellow Luke Chen in Taiwan group, he put that tiny fourth on it. Okay, so what he did was he had a target compiler, which was based on Win32 fourth and the TCOM. Okay, so he had this meta compiler, and he wrote assemblers for he wrote a universal assembler. In that this assembler can be adapted to any microprocessor with a few tweaks. Okay, so he generally was the first person who have forced to run on a new chip. So he sent me this tiny fourth. It was very interesting, but you know, his meta compiler was really complicated. Okay, and I find it's very hard to understand and very difficult to use. But in spite his claim that his assembler was the easiest one to use. Anybody can do it. So that's but that was inspirational. He was able to put that very little force inside the 2K flash memory. I thought, well, you know, yeah, if I were to do it, porting E-force over, you know, what should I do? Okay, so I just take out all the take out the compiler, and only leave the interpreter in it. And I only include only the commands that's necessary to build up this interpreter. So it's you know, trim everything down within 2K, and it does it's okay, and you can do a few things. So that was. And then in 2012, slideshow beginning. I think in the May of 2012, Kevin found that they released a new version, and with 2553 chip on it. So that chip has 16 kilobytes of flash memory. And that sounds reasonable. And Kevin offered to loan me his kit. I happily accepted, and then worked on it, and eventually put the complete E-Fort on this board. So this was the presentation I did in July 28th, 2012. Okay, let me just scan it briefly. This is the kit, and the first 2231 microcontroller has only 2 kilobytes of flash memory, and only 256 bytes of RAM. So that was a LaunchPad 1.3. And then with the 2553 microcontroller, you have 16 kilobytes of flash memory. And that's much more reasonable. But at the time, the document says that the chip doesn't have external, I mean, on the kit, it doesn't have external oscillator, but it has the external pins for a crystal. If you don't install a crystal in the socket, the 1.1 megahertz internal oscillator runs fine, but the frequency is not accurate enough for any to support any communication protocols. So this is a Code Composer 5.2, and I did for the smaller chip, it's the 430 microfourth, and then for the real one, it's a 430 E-fourth. So it was in the time frame of in the middle of 2012 that I did the implementation. At the time, there's the Arduino Uno came about, and was a really hot stuff. And the ST Microsystems also released the STM8 Discovery, which is just like a board like it, but a little bit bigger. Very cheap, kind of useful. So I at the time I released three E4 systems for the LaunchPad, for the Arduino and also for the Discovery. But I put them on my website, and my custom is to charge anybody want that system. That's $25, and but you can get the object code for free if you really want to try it. So but only Arduino has traffic, and nobody seems to be interested in the LaunchPad or the Discovery. At least I don't get any orders. So I thought, well, nobody's using it, so put it on the shelf and do other more interesting things. So it was there for 2 years, and only a couple months ago, some German fellow asked me if I want to have 430 E4 on their IDE. So they develop integrated development environment, presumably on some kind of forth, and it just replaces the Code Composer Studio. Okay, Code Composer Studio. It's a very complicated environment. Of course, it is targeted to compile C code. Okay, I use it just to assemble the E4. But the IDE was big. It's a huge application, and then people generally have trouble getting it started. So what these German people did was try to leverage this low-cost LaunchPad and build systems so that the students can actually make use of it. So what they did was provide an IDE. The IDE, you can download object code to the chip, and it also includes terminal emulator. Okay, so you can actually, once you get the forth downloaded, you can actually interact with it, and then it has a very nice terminal interface. You can download files, and you can save the sessions. So later on, you can actually reload the stuff from the screen. So, and they asked me that, do you want 430 E4 being bundled to this IDE? I wasn't thinking very clearly, and I was so we went back and forth kind of many times, and until I sent them I think one of the guy had already purchased this 430 E4, so they were able to bring it up, and so they actually bundle it with the IDE and send me a copy. I was pretty impressed. So let me go to their website. Hey. Okay, this is their website. They call it 4E4. It's actually, let me see if I can screw it up. Okay. It's fourth for education. Okay. I don't know. It's a fourth for education. So 4E should be placed on the end instead of head. But anyway,
They started off, excuse me, they started off being €4 forth.
Uh-huh.
Because for €4, you could get an MP430 with 44th on it.
Uh-huh, okay.
And they were selling the whole smear rolled up.
I see.
Okay, so it has a 4E4 on the LaunchPad. Okay, and that's Camel forth from Brad Rodriguez. Well, at that time I didn't. They sent me the system,
But so I dug up my kits, found my all the things on my shelf for 2 years, and tried to get the eForce running. Doesn't run. I got 4 chips and 2 boards. None of them work. I was kind of panicked. The worst thing is that the reset button doesn't reset. And if it doesn't reset, you really don't know. I really don't know where I was. And so for some time, I wasn't able to get the eForce running, and I said, oh, maybe I have to retract the eForce from the web. But the German guy said the eForce 430 eForce they downloaded from the web worked on their systems. They brought up the Code Composer Studio, and I was able to actually compile and assemble it, and actually download and actually run. So that was very, very reassuring that it's my board. Okay, it's my board, it's my chip, and things is okay. But it still kind of puzzled me as to why things does not work. I did lots of search, lots of experiment, and finally, I think in one occasion, I got the eForce to come up. So I said, okay, I got it up once. There must be, things are still okay. Software didn't break, and so I keep on doing things and start to work. But it's that the some things failed, okay, but I just couldn't really pinpoint where things failed. But computers despise newbies. So if you, I think it was, I made a mistake to show the computer I'm a newbie, so the computer just would not work for me anymore. But that you work on it, finally get things to start to recover. For the eForce 433, because I only knew that this 1.1 megahertz internal clock is not accurate enough to do accurate baud rate for UART. So I did a software UART. Just when it boots up, it's just there waiting for you to strike the B key. Okay, if you hit the B key, send one character over, and the force is there listening, and from the B key, it calculates the baud rate, and then communicate with you at that particular baud rate. So when it's running at 1.1 megahertz, I can only push the baud rate to 2400. Anything higher, it's become unstable. But these guys, the 4E4 is running at 9600 baud. I was wondering and then asked them, how did you do it? How did you do it? And so they sent me the code in the camouflage, the UART and the clock initialization code in camouflage. It looks simple. It looks reasonable. So I changed the code, incorporated the new initialization code. Nothing worked. Okay, this just won't talk. So I spent quite a few days wondering what was wrong. You know, sometimes I got some strange characters showing up, but most of the time the UART was just complete silent. So I tried lots of things, and you know, I don't have an oscilloscope. I was very proud of myself that without an oscilloscope or without a logic analyzer, I was able to, you know, implement lots of force, and even on the FPGA, bring up that EP32 chip, or without an oscilloscope. But this time, I was really missing that oscilloscope, not knowing what the UART is doing. That was killing me. But after a number of days of you know, doing this, doing that, and also using the code composer to look at the UART device, look at all the registers. So finally, I said, well, I asked them how they did the UART, and they told me that the PI inside the chip, there is a calibration table, and in that table there are calibration constants which can configure this clock to run very accurately at 1 megahertz, 8 megahertz, 12 megahertz, and 16 megahertz. So the calibration constants are all there. And you just, when you boot up, you just pull out the constants from that table, actually 2 bytes, and store in 2 registers. That's it. That configures the oscillator. And the oscillator is called DCO. It's digitally controlled oscillator. So you actually can control the oscillator with software. Okay. You can configure the oscillator has a resistor to supply current to it. So that's a big step. You select 8 big steps of currents going into the oscillator. And there's, I think, 8-bit, an 8-bit constant that can configure the frequency, fine-tune the frequency. So you can actually do I think the spec says that it's the accuracy is up to 3% or in the range. So 3% is good enough for UART. And finally, I said, well, let me. I have found out where these constants are, where the registers are. So I said, well, just take a look at the table. And then I found of the 4 chips I had, 3 of them has been erased. Okay, I don't know how or why. Only one has a FF value. So,
Did you just buy bare chips?
hmm?
Did you just buy bare chips?
No, I have 4 chips.
Did you just buy the chips, or did you buy them on LaunchPads?
I have, I think, 2 chips from the LaunchPad and 2 more chips that are ordered separately. And even with that chip that's with the constant, I plugged it in and it still didn't work. Well, I didn't know what I was doing anyway. So then I told them that my problem and send them the code that I modified according to the instruction. And the guy, Doc Rule, and he said what? He assembled my code, and the UART works perfectly on his LaunchPad. Okay, so the code is okay. My modification is correct, but of course the problem is I have erased the calibration table, and so he was very kind, sent me 7 fresh chips in the 2-day priority mail.
From Germany?
Yeah. So that was at the weekend. So I was waiting until Monday, and the mailman knocked, and my wife looked at the mail and said, "What is this?" Give me a box. Oh yeah, sure. That's what I'm waiting for. And for sure, plugging a fresh chip, it worked. Okay, so it's very happy. I was very happy. You see using the software on UART. You know, it's really a student basically cannot handle that. They need something which plugs in and boot up right on. Okay. Any distraction would cause them to just walk away. So here, I have the new 430 E-Force running at 9600 baud, and that's the main thing. And here, let me show you. Oh, the IDE. They have bundled the Force with an IDE, and let me show you okay, that's the IDE. So it's very similar to the hyperterminal, but now we don't have the hyperterminal since Windows 7. So I'm very happy to have this thing. Okay, let me see. Okay, it's so I have it on here, 9600 baud, and words. Okay, let me see. I have download. Okay, select file. 430E4. Okay, yeah. Here, it's just the hello. Okay, let me do hello. Oh, all right. Words. Okay, it didn't get compiled. Let me do it again. Uh-oh. Okay.
What's out?
Well, it used to work. Okay. Now,
let's see if that's a good point to a good place to show. Here is the flash, the LaunchPad. Okay, I think let me go do the flash. Oh, disconnected. Okay, stop it. All right. This 430 E4. That's the original 430 E4, which has the software UART. So I really don't want to download that one, and I need to go select a good 430 system. Okay. Let me see. I hope it is still on. Oh, I lost it. I got the where things are. What's this? This is a step I still haven't learned.
Oh, okay. I have not been able. What it requires, what this IDE requires is in the file in the hex format, and they configured and call it A43.
It has to be in that format, and I don't have it there. I haven't learned how to generate that file yet. So what I can do is go back to go back to my trusted code composer. From there, I can do the download. Okay, here is the 430E4_5. That's my latest version. And this has already compiled, but I can do the compilation, the assembly. So it assembles.
Errors.
Lots of errors.
It's not that complicated, okay?
But I don't. Okay.
Nothing to be done for all.
I think. Okay. I think I can run it, do the debug, and the debug would download. Okay. Okay, the debug starts. So if I just push this resume button, okay, and I hope it's going to sign up there. Okay, it didn't because I haven't started yet. Start. Okay. So that's how you know I get these to work. But if I have, I was able to generate a hex file from the code composer, but the hex file is not the same format as the real Intel hex format, so I cannot use it for downloading. I have to learn how to convert the object code into an A43 file. Okay, so this is the E4, and I think I was able to download lots of things, and I was so happy. Let me just try number 5. Oh, 8 error. I don't know. No, it doesn't work. Let me go back. Let's start again. Okay, compile only words. I think it is the I think it was that somehow it missed a character or something. This is the theory that Jack built. It's theory. This is the theory Jack built, and all this. Okay, that's it. Yeah. Okay. It's a pretty good. Let me see. Let me try to download the number 10. Lesson number 10. No, that's it. That's multiplication table. Okay. I forgot what I have the calendar in it, and I can show. Should be able to show you any month, the calendar any month. But that's pretty much. I can do pretty much the demo that I can show you. Okay, so this is the E4 chip, and let me see. I got the. Let me remove this guy. And this board I loaded the 4 E4. I hope it still works. Okay. Let me see. Usually this one, that board is on COM6, and this board generally it is on COM5. So let me stop it. And so here is the property. I think it is COM5. Okay. Oh, I think it died. Okay. Let me. Okay, this is the IDE. Let me throw it away. Where's the program? And go back to the IDE that's delivered. And this is Dirk, and this is Actually,
The executable?
yeah. This wait. I think this is the no. This is the one they configured for me for the E4. What I want to get is the original. Yeah, here. This is the. Okay. Yeah, it sees COM5. Okay, properties 96 COM5. Okay, save. All right. And I hope this is what. Install. Okay, that was some strange characters left from the last session when the R rate was not correct. Okay, and I think it should work. Okay, it doesn't. Okay, now let me do the download Flash and 4E for if I download this file. Okay, it their IDE calling some other program to do downloading. Okay, now it checks the okay, download is successful. If I do this, why it stopped? It should have a start here.
There it is.
Okay, yeah, all right. Works. Okay. So that's the camel E4, camel 4th. Okay, it's very good. Okay, it's case insensitive, and many more things than the E4, but it is. I think Camel 4th has been there for years and years, and he did lots of implementations. It's a very good one. But it is, I think it is direct threaded, either direct threaded or indirect threaded. I think it's indirect threaded. Very old style. And I'm using subroutine threading. So I thought that I could be should be faster than this one, but when I wrote some loop tests, no, mine's slower. So I can't brag on it. Generally, subroutine threading should be faster than the indirect threading.
But yours is optimized for a very small core vocabulary. So you're trading off that and getting started quickly with speed of execution.
It's generally subroutine threading is much faster than direct or indirect threading, because a subroutine is just a subroutine call, okay, and high level, low level, that's the same. It's just that it relies on the subroutine, the subroutine call and return instructions of the host computer. And in the direct threading, indirect threading, you have to have inner interpreter to interpret the list. So that definitely is slower. But I always try to compare the loops. I use for next loop, and he used the do loop. And it turns out the do loop is faster than for next.
Sorry.
But I think the do loop, when you test only the empty loops, it's just testing the next against the loop instruction. These two instructions, depending upon implementation, can be faster or slower. But if you execute lots of force code, and when you do the deep nesting, I think the eForce should be faster. Okay, so I think that's generally the procedure. You see what this for eForce, the user interface. It has the integrated terminal emulator, and it has the downloader, so you can actually download the stuff to the chip. It doesn't have the compiler and assembler and all these things, so it relies on some other tools to compile the A43 file. And once you have that file, you can do the downloading testing. And generally, that's what the fourth programmers needs. You just have to be able to download, write your code, test your code until you can until you are satisfied with your code and save the image. So this IDE has the capability of save the image, so that next time it loads up, it will execute the application. But
when it does that, does it pull an image back from the target, or does it have an image that it has made, and that's what it saves?
I haven't tried it. Oh, okay, yeah. So I really don't know. But in the eForce system, when you compile new words, it's compiled directly into the flash memory. So when you compile, do the colon definition, all the code are already saved in the flash memory. And the only thing and that when you boot up, the user variables are copied from the flash memory, the body of the code. So when you finish the application, if you don't do anything and reboot, push the start key, it would use the original user variables. So basically, what the dictionary was trimmed back to where it was. In my force system, these user variables are saved in the information flash, which is a separate area of flash memory, just next to the area that the PI saves the calibration table. Okay, I put my user variables there, so that if you have the application done, tested, you are satisfied, you just copy the user variables, the current user variables, including the correct dictionary pointer, back to the information memory and information flash. And the next time when you boot, your application will be done. Okay, so it's just to the code, when you define colon definition, the code are already put into the flash memory. All you have to change is this boot up user variable. And if you do that correctly, you get your turnkey application. Okay, I think that's all I can show you. If you any questions?
The 4E4, these are all free. Everything's free, including camel forth. You can get all the source code. Okay.
The 44th is sort of descended from Camel Forth. It's can't get 44th from Rodriguez.
No.
You can get it from
Yeah,
44th.
right. Yeah. You can get the camel forth from camel forth. Yeah.
It's a different thing.
Yeah. But I don't know the difference and what they have modified. Okay. Any comments? Yeah. Yeah. Yeah, I think TI has the. Yeah. Not on this chip. Not on this particular chip, but TI has wireless chips.
Right. They have 430 with the Bluetooth stack in it. They have 8051 with the Bluetooth stack in it.
Yeah, I know that's quite ready for prime time.
The 51 is. I've got one.
Yeah. Well.
The wireless stack, the Bluetooth stack from another vendor.
They have to pay for it. TI does have the stack.
Yeah.
You know, they Coin didn't use it. And now they're asking for it.
Remember the clock, the watch, the watch TI that has the wireless.
Right.
Yeah.
Do you remember which processor that was?
Oh, it's another version of 430. 430. Yeah. Yeah.
But that was full Bluetooth.
I don't remember.
Okay. That's some of the others. You got to remember the Bluetooth low energy. It's only been out, I think, less than a year. It's very,